Hi, this is John Linneball of John Linneball Tutoring, and this is SAT Trigonometry. Here's my contact information if you wish to contact me, and please don't forget to like, share, and subscribe if you like this video. SAT Trig is easy, and of course by trig I mean trigonometry, not a trigger, ha ha ha. All you have to know is right triangle trig, practically no unit circle, etc. You really just need to know the basic SOHCAHTOA functions, that is, sine, cosine, tangent. That's why I made this video. Knowing this SAT trig is an easy way to increase your SAT score. The book that I used for a lot of this, SAT Premium Study Guide from Barron's, likes to make the other point that, oh, if you don't really know this, you shouldn't waste a whole lot of time learning it. This should be far enough in advance of your taking the SAT that you'll have time to learn it. It's really easy, as you'll see in this video, so I would suggest you learn it so you can get the extra points. I will also release an ACT trig video very shortly. The trigonometric functions. Alright, there are 6 trigonometric functions, but you only really need to know 3 for the SAT. And those, of course, are sine, cosine, and tangent. So sine of A is going to be the opposite over the hypotenuse. So this is angle A here in red where it says angle. And so the opposite is this side here. And you divide that by the hypotenuse, which is always the longest side of a right triangle. And that gives you sine A. So you just divide this by this. Done. Cosine is the adjacent over the hypotenuse. Adjacent is one of the sides of the angle. It's not going to be the hypotenuse, it's the other one. So this is called the adjacent. It just means right next to something. They use the term adjacent a lot in real estate ads when something that's in a not so great neighborhood is next to a really great desirable neighborhood. They'll always say, oh, it's great neighborhood adjacent. So if you want someplace to look like it's in Malibu, you might say, oh, it's Malibu adjacent. That's what I'm getting at. So the tangent, of course, is going to be the opposite. So this thing here again, divided by the adjacent. So just this over this. Now, if you're wondering what these other ones are, the cosecant is just 1 over the sine. So instead of opposite over hypotenuse, it's the hypotenuse over the opposite. Secant is just going to be 1 over the cosine. So instead of the adjacent over the hypotenuse, it's the hypotenuse over the adjacent. And the cotangent is literally you just flip the tangent. So it's 1 over, instead of opposite over adjacent, it's adjacent over opposite. So it's just 1 over the tangent. Really easy. So the easy way to remember the 3 trigonometric functions you need to know, sine, cosine, tangent, just write down sine, cosine, tangent like you see here, and then you go opposite hypotenuse, opposite adjacent. But John, that's not easy. Right, so just write O, write Oscar has a headache over algebra. Or you can write SOHCAHTOA, so S-O-H, ka, C-A-H, TOA. Okay, and you can see this is always the hypotenuse, this is the opposite, this is the adjacent if we're using this angle here, represented by the Greek letter theta. So again, either use SOHCAHTOA or Oscar has a headache over algebra. Trig functions are ratios. That means they're the same for similar triangles. So what are similar triangles? Well, similar triangles always have the same angle measure. So here we see angle A is the same as angle T, angle B is the same as angle U, angle C is the same as angle V. So then it doesn't matter if the sides are different lengths because the sides that are across this from the same angles, they're going to have to be proportionate. So we can see that UV has to be proportionate to BC. TV is going to have to, or VT, whatever, is going to have to be proportionate to AC. So we can see that, or they have it as CA and VT. So that means these ratios are always going to be the same. AB over TU equals BC over UV equals CA over VT. It's going to be what they call the ratio of similitude, or similarity, if you will. And I like to use the fraction notation with the line between the AB and the TU. If you like to use ratio or AB to TU with the colon, that's fine. I don't find that particularly helpful, but if you like it, great. Similar triangles and trig ratios, again, same thing. So we can see that PR and BC are similar because this is 3, you multiply by 4, you get 12. We can check it using the other sides. Okay, BA, that's 5, that's 20. Okay, you multiply by 4 to get that. 4 times 4 is 16. Okay, AC is 4 times 4 is QR is 16. And we can see that there's a right angle here, so it has a hypotenuse. Pretty good bet that since the side lengths are all proportionate and it's a right triangle, that these are actually similar triangles. And in fact, that's how you can tell, is because the ratios of the corresponding sides are the same. So the three basic trig functions, sine of q, that's 12 over 20. We'll notice that sine of a is 3 over 5. You can divide the 12 by 4 to get 3, divide the 20 by 4 to get 5. Wow, it's 3/5. It's the same thing. Cosine of q is 16 over 20. Cosine of a is 4/5. Same thing. Divide both 16 and 20 by 4, you get 4 over 5. Tangent q, 12 over 16. Divide both of those by 4. Hey, you get 3 over 4. So we know these ratios are equivalent. It's great. As long as the triangles have the same angles, the ratios will always be the same, which makes it very, very good for things such as the ancient Greeks used triangle trigonometry to mark off beachfront property, where sure, they could set up one angle where it was not going to be washed away by the tides, but once they knew what the lengths were, they could just measure from that angle to figure out where the sides that had been washed away, well, the sides where the markers had been washed away would be, so that avoided a whole lot of dispute over who owned what kind of property. You know, Petrikos says he owns it, but Nikos says he also owns it. How do we figure it out? Okay, that's how. Another way to look at this. Similar triangles have the same angles and proportional sides. So sine, cosine, and tangent for the same size angles are the same for all similar triangles. So if we look at this thing that I got off the internet here, don't worry, it's Creative Commons license. So the similar triangles are triangles in which the corresponding angles have the same measure. The corresponding sides in similar triangles are proportional. So we know that these proportions are all going to be the same. Why? Because these angles are the same. You can see this is the same as this is the same as this. That's what the one line means. They all have this particular angle, angle A. And then these are all right angles, so of course they're equal. So even if you didn't have these marked, you could see that since they all have this angle and they all have a right angle, when you subtract those two from 180, you're going to be left with the same angle in any of these. Good to know for the SAT. So we can see that sine of A is going to be 14. It's going to be the opposite over the hypotenuse divided by 37, which is 0.38. Then we're going to have 25 divided by 29 plus 37 also gives us about 0.38, and then the other one is going to be 35 here divided by 35 right here divided by 26 plus 29 plus 37, which is also 0.38. If you try these using your calculator, you'll notice that they'll round off a little bit differently on your calculator, but they all work out to about 0.38. So if we could do it a little more exactly, it would work out exactly, but there are rounding errors. Okay, so what kind of problems should we expect? Well, I'm glad you asked. The simplest problems will be ones where you have to figure out the length of a side or the measure of an angle using the definitions of sine, cosine, and tangent, and given side lengths and angle measures. So they're probably going to do something like this here. Again, Creative Commons license. We know this is a 30-degree angle. We know that this is a right angle, so we can also figure out that this is a 60-degree angle, but that's not that important right now. So if you want to find A and C, what you can do is you can say, okay, well the sine is the opposite over the hypotenuse. So when we're doing this, we know the opposite is 7, we know the hypotenuse is C, so we have to find C. So we know that sine of 30 is the opposite over the hypotenuse, which means it's equal to 7, which is the opposite divided by C. So then we can just manipulate that to get c equals 7 over sine 30, which is 7 divided by 0.5. Sine of 30 is 0.5. 7 divided by 1/2, or 0.5, is the same as 7 times 2, which is 14. So c equals 14. Tangent of 30 is going to be the opposite over the adjacent. Okay, so we can see a is the adjacent. Again, it's going to be 7 over the adjacent. So we do the same thing. A equals 7 divided by tangent of 30. If you put that into your calculator, we see it's about 12.12, and in fact, we can do that pretty easily here. I'm just going to use my handy dandy Windows calculator, and we can just go 7 divided by, we're going to go 30, trigonometry, tangent, bump. So we get 12.12, and we're just going to truncate it there. We just round it down because that's a 4, so all right, 12.12. Okay, we can also check this using the Pythagorean theorem if you don't believe me. So we can say a squared equals c squared minus 7 squared. So that's going to be 14 squared minus 7 squared. So I can do it the fancy way where I can say, hey, that's a difference of squares. So it's going to be 14 plus 7 times 14 minus 7, which is 21 times 7, which is 147. So that's fancy. Or we can just square it and get 14 squared equals 196 minus 7 squared, which of course is 49, and get 147. So a is going to be the square root of 147, which is also 12.12. And I can even do that for you in case you don't believe me, which you probably shouldn't take everything I say on faith. So 147 second square root, yep, 12.124. All right. Isn't that amazing? All right. So a couple more basic problems. If sine of A is equal to 3/5, what are cosine of A and tangent of A? So first we draw a diagram. So okay, we can draw A, and we see A right here. In case you're wondering why I ended up over here and stuff like this, I'm having to use the touchpad on my laptop, and I'm wearing reading glasses that make it easy to see the screen, but not always easy to see the cursor, so I have to play around with it a little bit. Anyway, we have A here, and the cosine is going to be 4 divided by 5, so that's going to be the adjacent over the hypotenuse. I'm sorry, I skipped around a little bit here. Okay, sine of A is 3/5. All right, so sine of A, we know it's going to be the opposite over the hypotenuse. It's 3 over 5. So if you don't know anything, you can say, all right, I can always use the good old Pythagorean theorem. So I can just go, well, all right, I know that the hypotenuse 5, we can square that. 5 squared is equal to 3 squared plus whatever this is. And then you just figure out, okay, well, that's going to be 25 minus 9. 5 squared minus 3 squared is going to be equal to 16. And hopefully you should immediately know that 16 is 4 squared, so you know that this is 4. And then when you need that to find the cosine, you just go, okay, the adjacent is 4 divided by 5. The cosine of A is 4/5. The tangent is the opposite over the adjacent, so that's going to be 3 over 4, so tangent of A is 3/4. And if sine of B is equal to 5 over 13, okay, again, we're going to draw a nice right triangle. So here's our right triangle. We know that 5 is the opposite. The hypotenuse is 13. Hopefully you'll just know that a 5, 12, 13 triangle is a really common kind of right triangle. If you don't, you can say, okay, 13 squared is 169. Either know it or use your calculator. And then we know 5 squared is 25. You subtract it, 144. Square root of 144 is 12, which hopefully you can just figure out on your calculator, or you should know it. I do suggest that you memorize the squares of integers from 0 to 20, or at least 0 to about 15, because it's going to help you a lot on SAT type problems. So once we know that this is 12 here, that the adjacent is 12, then the cosine is going to be adjacent over hypotenuse, so that's 12 over 13. And the tangent, of course, is going to be the opposite over the adjacent, which is 5 over 12. All right, So let's go one step beyond the basic problems. If the sine of A is 3 over 5, what are cosine of A and tangent of A? Well, again, we're going to draw a diagram. So we do it just the way we did. And, anyway, this is the problem we just did. So sorry about that. Okay, you could be asked to find the measure of one or more angles in these same triangles that we just did. So, for example, angle A's measure is going to be inverse sine. That's what it means when it's sine -1 is 3 over 5. So, okay, well, why? Because angle A, okay, we know its sine is the opposite over the hypotenuse, which is 3 over 5. So you just plug that in. So you go, here we go, on our calculator. We're just going to go 3 over 5. In case you don't know, it's 0.6. But let's do it the dummy way. Let the calculator do the heavy lifting here, because it's really stupid to get something wrong on a calculator section because you thought you would show off and do it in your head. So, all right. So now we want to do trigonometry. We want to take the second function, so we get the inverse. So notice it's sine to the -1, so that's the inverse. Just like anything to the -1 power is 1 over it. Get it? Ha ha ha. So it's the inverse. All right, so we get 36.869, so really it's roughly 36.9. So that's our answer there. Now I'm just going to keep this open so I don't have to keep doing that. So 36.87. All right. And therefore, angle C's measure is going to be the inverse sine of 4/5, which is the inverse sine of 0.08. I know that, so anyway, it's 0.8 rather, not 0.08. So that's going to be trigonometry. Come on, trigonometry. And that's 53.13. Okay, so we know that's 53.13. Great, so we can figure out those angles. Same idea, the measure of angle D is going to be the inverse sine of 12 over 13. Okay, so we go 12 over 13. All right, that's 0.92, blah, 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 blah. Inverse sine, okay, 67.38. All right, so you can be asked to figure out these angles, especially on really only on a calculator section on the SAT. They don't give you those tables of sine, cosine, tangent that they used to give you on long ago math exams when people didn't necessarily have calculators that did inverse sine, cosine, and tangent. So, slightly harder problem. All right, we could give... I'll try that again. Okay, they could give you a problem like this where they give you one triangle that's split into two right triangles. So we can see that this is like that, and we can see this is going to be forming a right angle with the ground. And I've labeled this is transmitter A, this is transmitter H. So, or maybe it's just a radar tracking dish. Well, anyway, it's got a transmit and receiver. It won't work as radar. So, whatever. We know that this is 20 miles from point A, transmitter A, to C, a point on the ground that's directly below the plane. And then K is going to be the hypotenuse of this right triangle that goes directly to the plane. And H is going to be the same thing. It's going to be the hypotenuse of a right triangle formed by transmitter B and point C. So, okay. So we want to know how high in the sky is the plane. How far is in a straight line is the plane from transmitter A? How far in a straight line is the plane from transmitter B? How far from transmitter B is the spot on the ground directly under the plane? That is point C. So how high is the plane? Well, this is the first and the easiest. Tangent of A is going to be the opposite over the adjacent. We already know the adjacent because they gave it to us. It's 20 miles. And so basically tangent of 15 is going to be equal to O over 20 miles. So then you just multiply tangent of 15 times 20 miles, which is 0.2679. And we can check that just in case I made a mistake. I don't think I did, but let's see. All right, so that's 0.267 times 20. So we're getting 5.358, so roughly 5.36 miles. All right, so sine of A is going to be O over K. Okay, ha ha ha. So K, the distance of the plane, is going to be O over sine K, which is 5.36 over sine 15. And all right, we're going to divide that by, okay, put in 15, trigonometry, sine, boom, boom. So roughly 20.71 miles. And okay, so 20.7, close enough for government work, so to speak. All right, now sine of 35 is equal to 5.36 over h. So h is 5.36 miles divided by sine of 35, which is 9.34. Let's check that. All right, got to clear this out. 5.36, and that's going to be over sine of 35. Okay. Oops. Over, got to put in those parentheses. Sine of 35, okay, 0.8. All right, so that's 61.49, roughly 61.5. And let's see, I think I did something wrong here. Okay. All right, 5.36 over sine of 35. Over 35 sine. Okay. Yeah, so we get roughly 9.34. So, whatever mistake I made there, you always want to make sure that it's a reasonable answer. And really would not be a reasonable answer for it to be what I got before. So it's 9.34 miles. All right, so the tangent of 35 is going to be the opposite, that is O over A. So we know that that's going to be 5.36 miles over A. So A is going to be 5.36 miles. Okay, 5.36 miles over tangent of 35, which is 7.65. And that checks out, as we can see here. And that's an important lesson in why you always want to do your calculations twice, because that previous value was definitely way off until I did it again. Sometimes it's just the calculator doesn't clear out, or I didn't clear it out. I find that happens a lot when I use my iPhone, but you won't have that problem because you won't be allowed to use your cell phone as a calculator. So make sure you always check your things here. Make sure you clear things out before you do calculations. All right, and always do them twice. Trucks and ladders. Sounds kind of like chutes and ladders, right? Anyway, these are really, really common problems when they're asking you about right triangle trig, either in your algebra/trig textbook or on the SAT or the ACT. Okay, the ladder problem. This is the classic granddaddy of all right angle trigonometry problems with the right triangle. Here we have a 13-foot ladder that is placed against a wall that is perpendicular to the perfectly level ground on which the ladder and wall rest. So saying it's perfectly level, so we know that the ground here is a straight line and it forms a perfectly perpendicular right angle, so we have a right triangle. All right, the ladder touches the wall 12 feet above the ground. So you might be thinking, hey John, I think you're trying to set up a 5, 12, 13 triangle. You would be correct, because if the hypotenuse is 13 and one of the legs is 12, you know darn well that the other one has to be 5. If you don't know that, use the Pythagorean theorem, find out that 13 squared is 169, subtract 12 squared, which is 144, and you will get 25. And if you can't tell that 25 is 5 squared, I don't know what to tell you. You have to review your squares and square roots. All right. Okay, so I guess I did know what to tell you. Ha ha ha. All right. So what's the measure of the angle the ladder makes with the ground? Well, that would be angle A right here. The easy way to do it is we just go sine of A is going to be the opposite over the hypotenuse, which is 12/13. So all we have to do first is clear this out, clear it out again. Take 12 over 13. What do we have here? We've got 0.923, and we're going to take the inverse sine of it. So we're going to hit second, boom, 67.38 degrees. Was I right? You bet. I did it before I got that value. It's 67.38 degrees. Now you're probably wondering, what's this flashy dump truck doing here? This is really all chromed out and everything. This must be one of those show trucks. I don't think I'd want to use this as my dump truck. It's too pretty. But anyway, you can see they could give you the same problem with a dump truck where they say the rear angle, the lifted up, whatever, elevated dump truck bed or dump truck part, whatever, forms an angle with, the distance between the front end of the dump bed or whatever they call it and the flatbed of the truck is 12 feet. The length of the bed is 13 feet. What is the angle that the dump part makes with the flatbed of the truck? And you could figure it out the same way we did and reach 67.38 degrees. Angle of elevation and depression. If the object you're viewing is above the horizontal line of sight, the angle between the horizontal line of sight and a straight line from your eye to the object is the angle of elevation. So what I'm talking about here is this thingy. Here's your eye. All right, here is the object. The angle formed here is the angle of elevation. Get it 'cause it's elevated, it's going up. Angle of depression. No, it doesn't mean it's bummed out and needs Prozac. It means that the object you're looking at is down on the ground or down below the ground. It's down this way. Maybe this is a lake and it's underwater. Of course, then you're going to have refraction to deal with, but I digress. Anyway, angle of depression. Your eye goes like this. This is a straight line from your eye. You can see the angle between that and the line of sight from your eye to the object. That's the angle of depression. This distinction matters. Why do you care? Because you can know all the right angle trig, all the formulas, know how to do it in your sleep, but you can get the wrong answer because you didn't know the difference between the angle of depression and angle of elevation. So I'll give you an example here. A building is 500 feet tall. Excuse me. Barbara is parked 400 feet away from the building in a parking lot on a perfectly level street to which the building is perpendicular. Again, I'm setting it up so we know it's a perfect right triangle. That way some kid can't say, well, buildings tend to settle, so I have no idea if that's a right angle or not. And how do you know that the ground is level? Because I told you. That's how I know. Anyway, what is the angle of depression from the same building roof edge to the same bottom corner wheel? So anyway, the angle of elevation from the bottom corner of Barbara's car to the edge of the top of the building closest to it. Again, you have to be very specific. And then the angle of depression from the same building roof edge to the same bottom corner / wheel of the car. So I'm saying the space under the bumper and by the wheel, just imagine it's a rectangular prism. It's just a big block, and that I'm talking about the space that would be in the shade of the bumper and the wheel, at the very edge of the car. That's the bottom corner. So, okay. We know this is 500 feet. We know this is the bottom corner of Barbara's car. And the reason I say the bottom corner of Barbara's car rather than Barbara's eye is I don't know how tall Barbara is. If she's 5 feet, then this is, the difference is going to have to be 495 feet. 500 minus 5. I didn't want to make the problem that hard, so I'm just going to go, it's 500 feet from the very bottom of Barbara's car. I guess we'll pretend that's lined up. And, all right, so we know this is 500 feet. We know this car is parked exactly 400 feet away. All right, so we can figure out one, we can figure out the distance. We don't really have to, but we can for fun. We can say that, okay, 500 squared plus 400 squared, and you take the square root, you get 640.3. Okay, what? You're saying you don't believe me? Okay, fine. 500, we're going to square it, plus, okay, 400, going to square it, so it's 160,000. All right, so that's 410,000. Second, we take the square root, so that's 640.3. Okay, you believe me now? Good. What's that little sketch? Listen to me now, believe me later. All right, good. So anyway, it's 640.3, value for the hypotenuse, and you can use that to calculate the sine and the cosine of these angles. So you could take, basically, if you want to figure out the angle of depression from here, you could go, well, all right, let's see, this is going to be, the opposite is 400 over 640.3. Okay, so that's going to be the sine, and then you don't have to, because you already know this is 500 and that's 400, and the tangent is the opposite over the adjacent, so I already know that's 5 over 4, or sorry, it's 4 over 5 for this one, for the D, so it's going to be the opposite is 400 over 5, so I could automatically just go 4 over 5, which you probably know is 0.8, but if you don't, that's okay, now you know. And then I'm going to go second tangent, boom, 38.65. Let's say I want to figure out the other one. I want to figure out the angle of elevation. Well, as it says here, that's 5 over 4. Why? Because this is going to be the opposite, which is 500, and the adjacent is 400. So we can see adjacent is 400, the opposite is 500, adjacent is 400. So that's going to be 5 over 4. Hopefully you know 5 over 4 is 1.25, but again, why waste brain power on it when you're on the test, when you already got jello brain because you're panicking? Okay, it's 1.25. We're going to take we know that's the tangent, so we're going to take the inverse tangent. Hit second, make sure you see the tangent minus 1. Boom, 51.34. Okay, so we know that's 51, or we're rounded to 51.3 here. Boom, we know that. So we know this is 51.3. We know that this is 38. This is 38.7 here. And notice that these add up to 90. 51.3 plus 38.7. Again, if we just go 51.3 plus 38.7, boom. What? Oh, I subtracted. Dope. 51.3 plus 38.7. Again, always make sure that you check to make sure it works out right. It's always going to be 90 degrees. Okay. So you can, once you know one of these, you know the other, but you want to make sure that you're using the correct thing. If they're asking for the angle of depression, you need this. So it's this angle here where the person's looking down at this object. You don't want the angle of elevation from here to the horizontal. I guarantee you that will be one of the wrong answers on the SAT. Same thing, you want the angle of elevation, you don't want 90 minus it, which would be the angle of depression over here. Okay? So don't get them confused. Draw a diagram as I just did. It's a bonus if it's actually close to scale, so maybe you'll see if it's reasonable or not. You want to know elevation means going up, not hard, since elevation means height in most contexts. For example, the elevation of my hometown is approximately 500 feet above sea level. Make sure you know the depression means going down. So again, if we're looking at it like this, we can see, okay, depression, somebody's standing here, they're looking down on you. Okay. And depression means if there's an indentation, or if you're pressing a button, or if you're feeling down, if you're depressed. So it's not hard, but you don't want to learn it on the fly. You want to know this stuff before you walk into the test, because, well, it's like a lot of things in a book on survival. The preface to it was written by this Army survivalist who just said, hopefully you are not reading this for the first time when you are cold, wet, hungry, and it's getting dark outside and you're lost in the woods. So you don't really want to learn this sort of thing when you need it. It's definitely much better to learn it before you need it and be prepared, as they would say in the Boy Scouts. Make sure you read the question carefully so you know what was asked. Radians, you don't need to know much. If you're already working with radians, the unit circle, etc., great. You'll be more than prepared for the SAT and also for the ACT. Just do a little review. And you can set your calculator to accept values in radians or in degrees. Just make sure that your calculator is set properly. Obviously, if you have your calculator set up for degrees and you're trying to put in values in radians, or you're putting in values in degrees when your calculator is set to radians, you're going to have a problem. If you're not, just know that 2 pi radians equals 360 degrees. So pi radians is 180 degrees, pi over 2 radians is 90 degrees, pi over 4 radians is 45 degrees, and pi over 6 radians is 30 degrees. Basically, 1 radian is 180 over pi degrees, and 1 degree is pi over 180 radians. With that information, just remember 2 pi radians is 360 degrees. You should be able to figure out anything when you want to convert radians to degrees. And again, if you're not familiar working with radians, the unit circle, etc., just convert radians to degrees and solve. So for example, if sine of phi is equal to a, what's sine of pi plus phi? Is it a over pi, negative a, or negative a over pi? Well, since we know that pi radians equals 180, we know that sine of pi plus phi is equal to sine 180 plus phi. So we can just pick an easy value for phi, let's say 60. So sine of pi plus phi is just going to be sine of 240. So now just keep your calculator set to degrees, which it usually is, but do make sure it is. Maybe you hit the wrong button or something. So okay, we see DEG, it's set to degrees. So now all we have to do, put in 240, and we're going to take the sine of 240. We get negative 0.866. And so let's take 60, since 60 is our value for a. What do we get when we take sine of that? It's positive 0.866. Okay, so we know that that's minus a. So minus a is answer choice C. And here we go. Sine of 60 is 0.866. Sine of 240 is minus 0.866. So the answer is C, minus a. Did we even really need to know that much about trigonometry in general? No, just enough to do the question. All right, but we got the point, didn't we? Ha ha ha. What you don't need for the SAT, you don't need to know secant, cosecant, or cotangent. Those are good things to know for the ACT, however. You don't need to know reference angles, you don't need to know graphs of trigonometric functions, you don't need to know the law of sines or the law of cosines, you don't need to know the trig formulas for the area of a triangle or a parallelogram, you don't need to know double angle and half angle formulas or trig identities. But however, you will need to know at least some of these for the ACT. Guarantee you'll need to know secant, cosecant, cotangent, or at least recognize it if they give it to you. Same thing with the law of sines and the law of cosines. You're going to have to at least recognize it when they give it to you and be able to plug in values. Graphs of trigonometric functions, the ACT, they will ask you things about the period and amplitude and things like that, and how maybe multiplying or dividing it or something like that will affect those things. And so you should know those. You should also, of course, know those for your high school trigonometry course, and hopefully know that well enough that you won't have to take a course like quantitative studies or something like that in college. Anyway, you don't need to know anything you see on this PowerPoint slide for the SAT, so that's the good news. I'd like more practice, please. Okay, if you want more practice, you can find trigonometry help at the official SAT review site, which is Khan Academy, and they offer this. This is also in the description below this video. You can also see analyzemath.com/high school math, grade 10 trigonometry. You can see that too. Also YouTube, they have a very wonderful Regents exam prep video that I found here. So those of you who are from New York State, you know what I'm talking about when I'm talking about Regents exams. If not, they're exams you have to take in New York State, but they are generally very good math tests, and if something will help you study for Regents, it'll help you study for the SAT, the ACT, etc. And of course, the College Board has practice SAT tests available. You can just Google that, free practice SAT tests, College Board, and go to the College Board's website. I'll also put it in the description below. All right. Did you find this video useful? Please like it and subscribe to this channel. Neither action costs you anything, and you'll be alerted about my new videos. Why do I care? Well, it's simple. YouTube doesn't let me share any ad revenue unless I have 1,000 subscribers and 4,000 hours. That's 240,000 minutes of view time in a year. While many people are watching these, I don't have 4,000 hours of watch time, and I still don't have anywhere near 1,000 subscribers, although I keep closing in. I think I hit 650 today. Yay! Anyway, for the same reasons, you are not only welcome, but encouraged to share links to this video, put it in playlists, etc. I'm always happy to read and respond to constructive criticism or suggestions for new videos. I reserve the right to delete comments from and block those who specialize in destructive criticism, also known as trolls, or things that are off topic, spammers, disturbed people, people who just want to be heard, whether it's an appropriate place or not. If you would like to contact me, you can always call me on my cell phone. My cell phone is 415-623-4251. Again, 415-623-4251. You can call or you can text me on that. Email, it's john@johnlinnebaugh.com. Mail, 1859 Powell Street, number 109, San Francisco, California, 94133. Thanks for watching. Hope you have a great day.